it's the 5 beat, and they will show her that this is a quantity of 5, and it's actually easier, but you would have to tape it. So I would do it for all of the columns, right? Don't do it for the one column, do it for all of the columns. And then you would flip it. And then what would happen is you would do the same. So when we count it, right, if I line this up, this would be the horizontal bar, this is the horizontal bar, and then we would do 5. So we do 5. And you can follow the same. Should be, oh, yeah, that's fantastic. You know what? You know what? If you're really inclined to, I do have abacus workbook specifically for young children. That's funny. Mr. Clean. Mr. Clean, thank you for stopping by, but I'm curious on what your favorite food or dessert is. Favorite food is, I think it's going to be mango and sticky rice, or it's ice cream. Oh, I love ice cream. Okay. So, Rubber Duck, do you have a website? I do. It's the link in the bio. And this one is also available on the other selling platform. And I have that. Oh, that's not it. I have that. This is my name. Hi, welcome. My name is Lynette Young, and I sell books. I love abacus. I think abacus is the greatest thing next to sliced bread. Oh my God! And next to Betty White. All right. So, Alex, thank you so much. But people have called me horrible. I'm horrible. I'm horrible because I rant about the new math. I rant about mainstream math, and I'm like, why are we using all of this? Okay, so thank you, Alex. Thank you. Okay, so what we're gonna do, Rubber Duck, if I can call you Rubber Duck, what we're gonna do is we're gonna read the abacus. When we read the abacus, we're gonna notice, right? We have the 5. We're gonna have the 5 beat. For us, right? Because I have a dot indicator, because I have a ones indicator, I'm going to start here. For you, Rubber Duck, you would choose any one. I would start in the middle. Would I start in the middle? I don't know. Maybe, you know what? I'd leave 2 columns behind. So this would be your decimal. The reason why, because then you can start talking about money. So when you talk about money, right, we need the 1 penny, right? We do 1 penny. So $1 and 1 penny. So when I would do it, oh, I'd love to hear you read. You're Mr. Clean. You're so funny. So Rubber Duck, what I would do for your abacus, right? I would have 2 columns because why? Because then you can have the ones, the tenths, and the hundreds, and then you can convert it into money. You can use it to help you count money. Does that make sense? So then when you look at it, we have the decimal. The decimal just sits between. Don't have a dot on between the thing, right? You want the dot as an indicator. That's the indicator. Then you have an actual decimal that's invisible, right? And it would be between the ones and the tenths. The ones and the tenths, and then you have the hundreds. So then we can have our money, right? We can have $1.10. So it'd be $1.10. Does that make sense, Rubber Duck? So when you do your multiplication, that's what I would do. Keep it as a decimal, because you don't need to do more than 2 decimals, because when they get older, I mean, unless you want to graduate her to a higher abacus, you can utilize what you have and you don't need to buy a new one. There's no need to buy a new one. There's no need, because you just need to modify it, right? So then we can do 5. When we add the 5, this is what 5 looks like. On the abacus, that's what 5 looks like. When we have it on the 10-beat abacus, we would have it here, and we would touch the string, right? So then after that, we can do 6, and we would have to make sure that they touch the string. So this would be 6. Just as we have money, we have 5 cents, and then 1, and then that's just what I would do, right? You could use money as well. Yeah. So we have 6, and then we have 7. So this would be 7. So right now, what we're doing is we're learning how to read the abacus. After we read the abacus, then we can start adding, subtracting, multiplying, and dividing. It just depends on how far I crash. How quickly do I crash? But we're going to keep going, right? So the idea is to understand how to read the abacus. We have 5, 6, 7, 5, 6, 7. We add 1 more. This is 8. 5, 6, 7, 8. That's super cool. I didn't know you could use it that way. Yeah. So then we have 9. Right? We have 9. And that's what it is. So if you notice, that's exciting. It seems very intuitive. Yeah, right. It seems like it makes mental math easier. It does. You know, when you have those kids and they do this, and they do this, they're just being very dramatic. I'm just letting you know. Because really, it's just a flick of flick of a finger. But the ones that you see, the abacus, hello, Ashley, happy Monday. Gonna go, oh, really? Woo! Okay. Um, Good listening in while I work. That's funny. Oh. So, rubber duck. So when it is intuitive, however, you can push them to do mental math, but in abacus, we actually don't push them to do mental math. Why? Because we want to have them do all of the calculations on the abacus, and then after they understand it, like we take the abacus all the way to multiplication, division. We don't try to do mental math. We don't try to do. I don't push mental math. My boys, I have 3 boys, and they all learn the abacus. Can they do it in their head? Maybe, but I do know that they have a really strong sense of numbers. They have a really strong sense. It's just depending on how they do it, right? It all depends on how they work it. And then you'll notice that when we start going into adding and subtracting, we will start to go a little bit into algebra, but it's not as tough as you think it is. It's actually quite easy and very and it feeds very well into the abacus. And so that was the one thing. I was talking to a teacher friend of mine, which I'm trying to, anybody who is a teacher and you want me to teach your class, I am open to having a conversation. The reason why was because he was like, in abacus, not in abacus, in school, they always teach the kids how to do the, what do you call it, to focus on the sum. And I'm like, we don't focus on the sum. In abacus, we don't focus on the sum. In abacus, we focus on the add-in. Guess who's back? Yeah! Learn abacus with friends. Whoop whoop. Oh, I don't know if you hear my dog. Yeah. May I ask, how would you use this for addition? Oh, we're going to do it. Like 4 plus 5 is equal to 1. That's algebra and abacus. Yes! You're absolutely right. You're absolutely right, Mr. Clean. That is what it is. Yes, Alex, what we're going to do is we're going to do some adding and subtracting first. Then, after we do adding and subtracting, we will go into multiplication. But I think we're going to go to multiplication. Yes. So, the first thing we're going to do is the first thing we need to do is understand how to move the beads. So notice that the way I have this broken up is I look at the add-in. That's very different than the mainstream math. Mainstream math talks about what is 8? How do you make an 8? 7 plus 1 is 8. No. In abacus, we focus on the add-in, right? So we want to see 7. We have the 7. I want to add 1. I want to add this 1. I'm moving the beads to add the 1. Why am I doing that? Because I want to see how the beads move. When I understand how the beads move, then you'll understand why we're going to do some of the things. Why we do some of the things we're going to do. But Alex, thank you so much for the question. And you know what? I'm very open to all the questions you have. There's no dumb questions unless you tell me that I'm a horrible person. And then I'll just laugh in your face. Get out of here. Anyways, so what we're gonna do is we're gonna do 1 plus 1. When we do 1 plus 1, makes sense, right? You know what? I'm gonna turn on the light. I need to turn on some light so then we could see. There we go. Here, there we go. Much better. Okay, so maybe that's too much light. Okay, so what we're going to do, right? What we're going to do is we're focusing on the add-in. When we focus on the add-in, we just want to be able to move the beads. So we have the number 6. When I add the number 6, I want to add the 1 bead. So we actually just jumped through. We didn't do some number recognition, but that's okay. We're doing some. So in the beginning of the book, I just want to let you know, Rubber Duck, that what we do in the beginning of the book is understand how to read the abacus. So this is a little bit about the abacus. Oh, gosh, I would have never thought that actually would be beneficial. Yes, it is very beneficial to children. It's actually very beneficial to adults too, because it keeps your mind active. It's like doing brain gymnastics, like Sudoku, Sudoku, word searches, crossword puzzles, and I think that's it, right? What else do we do? What else do we do for brain gymnastics? Yeah. And so just so you know, Rubber Duck, what I do in the beginning of the book was to show the difference between the numbers, and I have them do tracing and stuff. And so we have this is an activity. They can do whatever, right? They could choose whatever color, and then the idea. I love Sudoku. Now the abacus. explain the counting again. It was left to right. Yes, it was. Hello, Anne Blessing. So then the idea was to find the number, right? Find the number 1, and then find the abacus here. So when we do it, is it left to right? It is left to right, Anne Blessings. When we do double digit, it will be more easy to understand. But what we are going to do is, because the way we talk about it is always going to be 54, 54. Right? Explain the counting again. So when we count, we do 1, 2, 3, 4, and then 5. Because we do 5, just as we write, this is 5. So what's going to happen is when we do 6, right? We have 6, 7, 8, 9, and 10. After 10, after 9, this is 9, right? And then this is 10. Just as we write, okay, I'm listening. Oh, good. So just as we write 10, it's a 1 and a 0. Make sense? So when we do 11, right, 1 and 1, 12, 1 and 2, and then 13, 14, and then 15. After 15 is 16. So it follows the way we write. It doesn't go outside of that. And it's the same thing. So if I wanted to, because that's a horrible whatever number that is. So if I do this, all of these beads are 5. All of these beads are 5. So that's not right. All of these beads are 5. So when I write, it'll be 55,000, 555 point, right, decimal, 55. Oh, I got you. Right. Exactly, right? It makes sense when there's a place value. It makes sense as a place value. And that's the other thing. So rubber duck, if you notice, the way we do it on the abacus, there's a place value. If you do the one that's vertical like this, I don't understand what kind of place value you do here. So for the ones that is vertical, the abacus that has the 10 bead across, they are strictly a 1-to-1 correspondence. However, in the abacus, the soroban, we actually do place values. So when we do the place value, I'm starting just for my ASA. Oh, interesting. Cool. How old is your child, may I ask? And so when we do this, we want to start them with understanding how to read the abacus. Just as I showed you, he's 10. Oh, okay, you know what? I do have this, which might be interesting for your child. It is a maze. Let's do the maze. We could do the maze together. This is cool. So she has books on Amazon. Yes. Thank you. Here's my name. I like your suggestion about modifying my abacus. Yeah. You know what, Rubber Duck? I'm telling you, you don't need to buy an abacus. You have what you got. The only reason what an abacus is moving pebbles. That's all what an abacus means. So we could do this. So what's going to happen is, thank you so much, budget. So what we're going to do is we're going to read the abacus. And I just published this. I'm so excited. So what is this number? Let's do a little activity. Let's do this activity. It's very visual. Yes. Do you saw the maze on Amazon? Yes, I do, Mr. Clean. I just published the 2 digit. I got to work on the 3 digit, 4 digit, the 5 digit with the decimal. So it's going to be 2 digits with 2 decimals and then 3. So I was going to do that. That's what I was going to do. It's going to be it was going to be a series. And then after that would be, yeah. So yes, I am going to play 61. Thank you. So how do we know? We have this. We have 6. 5, 6, we have 5, 6, and then this is 1. So right now this is 61. So what I'm going to do is I am going to follow the path. So I go 61 and I follow the path. Now the reason why I'm covering, what I have is because the answer is on the path. So that's why I have this thing called mask the maze. Because somebody brilliant told me, you should cover the answers because, we always see around, right? So then if this is the number, we have this number, what number would that be? Thank you, Mr. Clean. Yeah, I'm excited. I think I have like 10 books in my, thank you, Ashley, Alex, and Mr. Clean. Alex, 39. 30. 1, 2, 3. This is a 30 on the tens column, right? This is the tens column. And then, yeah, there you go. And then 39, we have the 9. Yeah, I'm excited. I'm excited too. Thank you so much, Mr. Clean. I'm hoping that this is like fantastic. Okay, so 39. We are at 39. You know what? It's really because you guys were really super 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 supportive and you guys found that this was exciting and I'm like, "Really? This is exciting? Okay, let me do more." So I actually have this like in my what I, in my vault, and I was going to be selfish and I wasn't even going to share it because I was like, who's going to want to do this? And then I have you guys, and you guys are like, oh my god. So I'm like, okay, I will share my all my resources. I do a lot. Like when I did a transition from my I was like organizing my Canva, and I have a lot of worksheets. I'm just trying to figure out how to organize it, and then I'll be able to publish it. So if you look, I have TPT. Oh, so you're passionate. So you're so passionate. That's what come. But don't get me on mainstream math. Woo! That one. Oh my god. It just ruffles my feathers. This one speaker was like, I learned how to do the lattice addition. And I'm like, okay, that sounds interesting. And then the speaker's like, but it was a little difficult. And I'm like thinking, if it's difficult for you, why are we teaching this to the kids? Oh my God. Okay, sorry. So what is this next number? We have this next number. We have this number, and then we have this number. So remember, we're talking about place values. We have our tens and our ones. So when we look at it, what number do you think that is? 51. Yes, exactly. 51. Hi, Mimi. No, 51, because this is a 5. Every top bead is a value of 5. Every bottom bead is a value of 1. So when we look at it, this would be what 11 looks like. This is what 50 looks like. Does that make sense, Mimi? So what we're going to do is we're going to color in the path. Yeah? Yeah. Oh, yeah. It's the attention to detail. It's the attention to detail that abacus like really hones in on. Because sometimes I'm like, I don't know if I'm doing this right. So it does take me a little bit too. I've been teaching, so everybody, I don't know if you guys wanted to know, I've been teaching abacus for about 20 years. 64? No, I'm not 64, but I'm close to it. You're right. You're right, Mr. Clean. It is 64. How do I know? Because we have 5, we have 6, and then we have 4. 1, 2, 3, 4. And then the idea also was if you wanted to, you could color it in. That's why I made it hollow. So you can do this. That was the idea. Thank you, Alex. Yes. So we are going to do 64 and then we color that in. So notice what we're going to do is because sometimes it's just easier to, that's the reason why I made it hollow. I'm seeing myself laminating these sheets for my son. Yeah. Oh, fantastic. Yeah. I yeah, I just bought a laminator too. And I was like, oh my God, this is so cool. So I have 1, 2, so then they can do it multiple times. But there's 20, the one that I have on my website, you can print it. Ooh, Lynette, it looks very, ooh, I saw you on my FYP. I thought you were 37. I wish I was 37. But I'm not. I'm so old. Thank you. Thank you, Alex. And I like it. I like being old because then my kids are old and then I have time to tell you guys about all the things about abacus because my kids are like, abacus again? I don't want to hear about abacus. I'm tired of abacus. But I like it. I really like it. Right? So we have this. And then if we look, we can do this. Right? We want to color it in. Ha, you guys are so funny. Well, if you think about it, if I started, I've been teaching abacus for 20 years, 20 plus years. I have, oh, good, 99. I actually have a learning center down the street, but my brother is taking over that, and I'm taking over the internet. I'm going to take over the internet, and I'm going to tell you guys. Oh, I'm telling you. And I got jokes. I don't act like a child. I don't act like an old person because I don't feel old. I feel stupid sometimes. Because if you look at my post, okay, so when you look at my post, I was like, this is funny. So I had that one with the knuckles, and I talk about, approved, and I was like, that's so funny. I'm very corny. I'm so corny, but I like it. Thank you, 91. So we're gonna go this way. So we're just following the boxes. We're just following the path. When we follow the path, then we'll be able to clean it. We'll be able to finish it. So we have that number, and we have this, and we have that. Okay, 75. Mr. Clean and Mimi. Wow, you guys are so good. Let me know if you have any other questions, but other than that, okay, 75. 75. We got to go this way. Okay, there we go. There we go. So we got that, and then we do this, and we do that. So we do this, 50. Oh yeah, there you go, Mr. Clean. Good, Mimi. Yeah? Okay. So that was 54. So we're going to do this, and then we're over here. So now we do this. Oh. So if you wanted to, and I do sell this one on my website, or you can get it at TPT. And it can be a downloadable, so you can download it and print it out and laminate it. Yeah. Oh, my TPT store. What's my TPT store? TPT store is where is it? Come on. There we go. So TPT store is this. That's my TPT store. English isn't my first language. I was easy to follow along. I bet you're amazing as a teacher. I hope so. I hope so. Thank you so much, Alex. Can I ask what your first language is? So, I don't know. 25. Okay, yeah, 25. I'm so curious. I just want to know. Like, I enjoy talking to everybody. I like yapping. I like talking and yapping. All right. Oh, hey! Are you in Germany right now? Or are you here in America? 53. No, not 53. 58. 5, 6, 7, 8. Mimi? Oh, okay. Yeah, because I do have a few people from like Norway, Sweden, Finland, England. Yeah. So I have a few people that actually come by. It's nighttime for you. Yeah. And they would come by at night. So we're at their last one. That's 58. Good, everybody. Good. So then I do believe my worksheets, my workbook is also available in Germany. I know it's available in France because I had a French person that bought 12 of them. Yeah. Okay, what's the last number? So we have this, and this. Okay. So we have that, and we have that. Yeah. When your kids are, 42. Yes, 42. It is the what? Is the answer to the universe. I don't know if anybody reads Hitchhiker's Guide to the Galaxy. So that's it. I hope you guys enjoyed that. That is about, so what we just did is we did bead recognition. And so what we did is we did bead recognition. The reason why we did it is so that we can see what we're doing, right? So this was trying to make it a little bit more interactive, more fun. And then this was going to be the second book. The second book is doing 3-digit. We can do that later, but I would like to go to adding and subtracting. Why? Because adding and subtracting is where it really is. You can do all the bead recognition really, as much as you like, not a problem. But after a while, you want to get into some adding and subtracting, right? So let's do some adding, and this is beautiful. Oh, thank you. That's the 3-digit. Yeah, and you know what? I did a new one. You know what? Let me take you on a trip. I'm so excited for this one, and I'll show you. I want to show you this. This is kind of exciting. The reason why is because I did a reverse. What does that mean? A reverse maze. So that means that let me see if I can find it. Let me find it. I'm searching. Okay, so here it is. Let me show you my reverse. Let's see if that works. Does this work? No, that doesn't work. Let's do this. I hope that works. I don't know where everything is. Where are you? Okay, good. There we go. This is not. All right, let's see. Okay, so this is my reverse. Oh, maybe I should edit it. No. Let's close this. There we go. So what this is a reverse abacus. Reverse maze. What does that mean? I'm going to give you the path. this is the path I'm going to give you. And then you're going to have to color in the number. Does that make sense? So I gave you instructions here, and it's part of the book. So it's like the first part is what we just did. The second part is the reverse mazes. And then I have it where you look at the path and you have to color in the number. So that's what I did. So here is start here 54. You got to put 54 on the abacus, and then you have to do 96. Oh yeah, cool. Thank you. I appreciate that. And then there's answers, and I have the answers in the back of the book. But what it is, and then what I have is I have 19 mazes for the reverse, and then 19 regular mazes. So this is part of the book, and that's like what I was working on. And then if you want extra, I can give you 14 extra mazes, but this is a download. And that's available to you when I get it. I'm going to be showing my future kids this. Whoa, that's fantastic. Okay, this is different. Yes, this is different. This is a different abacus. It is? What kind of abacus do you have, Anne? Because we can modify it like Rubber Duck. Rubber Duck had a 10 bead abacus, and I told Rubber Duck to modify to make it into a abacus like this. It's easy to modify. It's easy to modify. Even if you had a Rec and Rec, even if you had like a Right Start, you could do the same thing. So that was a little bit. Oh yes, you have a Rec and Rec. Is that what you're saying? So what I can do is I can show you how to modify. Modify. Yeah. Okay. So what's going to happen is, okay. So what I would do is, and it's horizontal like this, right? That's too many beads. So what I would do is okay. So what I would do is I would tape five. I would tape 5 beads together like this. So what we're doing is I'm going to show you how to modify it. And then I have 5 beads over here, just like this. So you can use what you have. You don't have to buy a new abacus. I don't believe in buying anything that you don't need. That's why it's one of those things, right? So when you do, I would do it for all of the levels. I'll just buy a new one. Why? It actually might be easier to do it this way. First, see if they like it. And so what I would do is I would modify it so you tape it. And then what I would do is then I would flip everything over. So it'd be like this. I would flip it and I go like this, right? Oh, I see what you're going to do. That's smart. Yeah. So what's going to happen is you have, this is taped together, right? This is 5. And then this is 1, 2, 3, 4. So when we do this, you want to get a string to go right in between. Really what it is just an abacus just means moving the beads. Even though, could you even add a string? Yes, you could add a string. You could do it you can make your own. There's been a few people that made their own, and you just put in a bead. You can make your own. I had some, but I don't know where I put it. But yeah, you can make your own if you choose to. Well, I don't know where it is. Okay, I'm done. Okay, so again, you're gonna have this is the horizontal bar, right? And with the horizontal bar, it would just look exactly like this. So what's gonna happen is you could do 5, right? And then 6, 5, 6, 7, 7, 8, 8, 9, 9, and then this is 10. 10 would be the next column over, right? And that would be 10. It would look like that. Does that make sense? Okay, I hate to say it, but I have to. That's what you said. This is the only class I love to read. Oh, thank you so much, Mr. Clean. Oh, that's funny. You know, there was another thing. There was another person. I think it was WWE. They were watching me in class and showed me to their teacher. And I'm like, oh my God. Yes, it does, right? Okay, good. So when you do it, when you label it, I would label the third bead, like here, this would be your ones. And then these 2 beads would be your decimal. So now you have pennies, right? So if I want to say $7.01, then you have your decimals. Does that make sense? So then when we look at it, hey Randall. So when we look at it, I'm so happy I stumbled on you. Thank you. Not a problem. rubber duck, not a problem. So when we do like 6 cents, then we do 6 cents. So $7 decimal, right? 0.6. So I would actually move it this way first. And then when they get used to it, then you can start talking about I think we use a similar system in preschool, but it seems a lot easier. This or this. This is different because theirs is a 10 bead, and the 10 bead is a very one-to-one correspondence. I know you go live when I'm places I don't even want to go. Mr. Queen, you're so funny. I try to go often. I try to go live often so you can catch me when you don't need to go places. But I do enjoy that you're here. Thank you so much for joining. I do appreciate it. You guys are so funny. Okay, so I have to go too, but I'll buy your book in the future. Not a problem, Rubber Duck. The 10B one. Yeah, the 10B one is the 10B one is a one-to-one. So so the difference is the corresponding. So when we talk about it, I think they did they were talking about like three plus 3 times 3, and they did this, right? 3 times 3. But the problem is with this is that you still need to count, right? I think it's better. I think I'd be better off with the small one because the new. Oh yeah, yeah. Okay, that makes sense because it's new and interesting. You know what? Before I forget, let me continue on giving you an introduction to the abacus. So there is this one which is nice and colorful. I like it colorful because I've been dealing with one where it has a lot of the same color, and this one's kind of cool. This one I would usually use for young kids. I don't know. You could use it for big kids. I like using this one because I like the colors, but I don't know if you have it around you, but there is a place called Daiso that sells this one, and it's a 13 column one. The only difference is the amount of columns because size matters. Yeah, placement would be good for him. Yeah, yeah. The placement for the abacus is very intuitive, and so when you look, it has exactly the same. It has exactly the same. There's an indicator. This is the ones indicator. This is my dot indicator. I could choose any one of these, just like Pokemon. I choose you. This one on the 13 column one, I like to be in the middle because then I have more beads to be bigger or more beads to have my decimal. On the 13 column one, if I choose this one, I can choose this one to be my ones. So then that means I can group it. So when I group it, I have my ones, my thousands, my millions, my billions, my trillions. Is there is there so there would be more decimals and bigger. Exactly. I'm going to use the Pokemon reference for him. Yeah, I got jokes. I got lots of jokes. But yeah, the Pokemon is what I was thinking about. And the other thing is, so we can talk about that in a little bit. But it works exactly the same. So if I line it up, right, we have our ones here and our ones here. If I choose the ones here, then I have a lot of decimals. If I choose the one here, then I have a lot of big numbers. So they work exactly the same, and it's all about the placement, the meaning of placing of the decimal. When you add the 5, you're only moving the top bead down. That's all you're doing. It doesn't matter about the color. The color just makes it look pretty. It's just there to be pretty, right? Does that make sense? So then when we do 6, we want to make sure that they are together like this. Notice it's the same thing. Notice there's no difference in it. So we have the ones, the tens, no, ones, thousands, millions, billions, and trillions. Trillions, right? Well, if you want to track the national debt, you would have to use a bigger abacus because size does matter. This is a 23 column one, and this is the one that I've been using for the past, I don't know, 18 years. And then I graduated to the small ones, right? So what's going to happen is it's the same thing. It works exactly the same. It's just bigger. That's all it is. It's just bigger. So notice I have the ones indicator here, and there's these 2 decimals here. So this would be like my tenths, right? So it'd still be grouped. Ones, thousands, millions, billions, trillions. I don't know what's after trillion. Quadrillion and then quintillion. I don't know. Now I'm just making up words, but it works exactly the same. And if you notice, you have to be careful. I feel like it's super easy once you get it. Yes, it is very easy once you get the hang of it. But And just so you know, you have to hold the abacus, because if you don't hold the abacus, the numbers will get ruined. Your answer will get messed up. So I don't know how quickly, kids are going to be kids and they're going to get upset if you bump them and then their answer is wrong. So make sure that when you're holding the abacus, make sure the abacus is being held. So I would usually use the left hand to hold the abacus. I'd have the right hand to do the calculations, just so you know. Right? So then the idea is to make sure that they hold the abacus, because it's very loose, very easy. Unless you get a Kramer abacus, and a Kramer abacus is a little bit stiffer. Yeah, a Kramer abacus is used for people who have vision problems, and so the moving the beads is a little bit stiffer. Yeah. Once we get the hang of it, there's a few things that we still need to do. We still need to add, we still need to subtract, and we still need to divide and multiply and divide. But this is the beginning parts, right? To understand how to use the abacus. When you understand how to use the abacus, it's easy to move. So this is made out of plastic. This is sold out in Daiso. I'm sure you can find it on the other platforms. TikTok Shop has a few abacus stores that do sell. I don't know. I don't vouch for them. I don't know if they're good or not. I do sell this one from my website. This is a 7-bead one, and I'm looking into, depending on how popular abacus gets, I will look into getting the 13-column one or the 23-column one. There is one that's 27, but I feel like it's an overkill. It just depends on how big your numbers are. The only reason why there's the big ones is because it depends on how big your numbers are. When I started abacus, this was the only one that was available. Now, since abacus, I don't know if abacus is being more popular or whatever, but there is now a little bit more of a variety. Do they all work the same? They all work the same. It doesn't matter if it's plastic or if it's wood. It doesn't matter. Yeah. Wouldn't you have just add one until the next? Wouldn't you just have to add till the next 5 or 10? No, we actually have to do a little bit more than that. There's a thing called formulas that we're going to memorize. Okay, so we understand. Well, so before I forget, let's go back to adding and subtracting. And that was the one thing, is like, we want to be able to add and subtract, right? So when we're adding the add-in. This is the add-in, and what we're going to do is we're going to make sure we add the one number. So we notice we have the one number, and we can minus the number. If we add, we go to the horizontal bar. When we subtract, we go away from the horizontal bar. So notice we have the balance of adding and subtracting. When we add, we go to the bar. When we subtract, it's away from the bar. Now, 4 is not very exciting. Neither is 3. Well, neither is 2. They're all not very exciting, right? So what's going to happen is, if I did 1, I don't know if I'm repeating myself. I've been doing this so much. 7, if I have 7, I want to add the 1. I'm going to add the 1. I'm going to add the 1 bead. This is the 1 bead I'm going to add, right? So this is what we're doing. We're adding the 1 bead. We can take away the 1 bead, right? Notice that I go to the horizontal bar. I'm adding the bead, makes 8. If I take away, so I have 8, take away 1, I take away, I'm moving away from the bead. So the question here is always going to be, do I have enough? Yes, we do, right? Just like Bob the Builder. Can we do it? Yes, we can. So the big question is like here. If I want to add 5, right? If I add the 5, I'm going to add the 4. Can we do it? Yes, we can. I'm going to add the 4. So my number is 9. So obviously, when we have to add, we can subtract. When we subtract, we have 2, right? We have 2, and we're going to take away the 1. Again, notice we focus on the add-in. We do not focus on the result. We don't focus on the sum. We don't focus on the blah, 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 right? We don't focus on here. We focus the result, the add-in. This is the add-in. And so when we add and we subtract. So again, and that's the way this book is broken up. We focus on that because it's always about the journey and not about the destination. It's always, what they say, marry the process and divorce the result. I like that. So what we're going to do is we're going to have the 3. We add the 3, and then we take away the 2. Notice it's these 2 beads. It doesn't matter what 2 beads, as long as it's 2 beads. It can be these 2 beads, or it can be these 2 beads. It doesn't matter, as long as it's 2 beads. If I had 4 and I need to take away 2, it can be these 2 beads. Right? That's simple. Right. It's simple. This is what it's called, simple. So can we do it? Yes, we can. This is the Bob the Builder. I don't know if you have Bob the Builder. my kids did not watch Bob the Builder so much, but they do know a little bit of it. So this is the Bob the Builder stage where we want to do it. Yes, we can. And again, we can do the same thing for the minus or for the plus 5. Plus 5, right, is plus the 5. And then if I have 1, if I have 6, if I have 2, right, I want to add the 5. I'm going to add the 5. Oh, yeah. Okay, cool. Okay, good. So yeah, so this would be like the Bob the Builder. Can we do it? Yes, we can. Do we have a 5? Yes, we can. So we're going to add the 5. We're going to take away the 5, right? So this is what we call simple. The reason why it's called simple is because we don't need to use formulas. So when we have 6, we're going to add 6. Notice I'm adding one bead on top of one, and I do it together. So I go 6 and take away 6. I add the 6, I take away the 6. I add the 6, take away the 6. So then I have 7. And it's the same thing. If I have 1, I have 7. I have 1, I have 7. 5, 6, 7. So I'm going to bring them together at the same time. When I take it away, I'm taking it apart like this. So I add 7 or I take away 7. So that's it. That is about adding and subtracting simple. So then the question might be, what happens? So notice in abacus, we actually have more add-ins. That's why we don't focus on the result. We have more add-ins. We don't just focus on 2. So this is where we do 7 plus 1, take away 5. And we take away the 5. And then my final answer is 3. This is why in abacus we focus on the add-in and not the result. Because we get more than just these, we get more add-ins. And then you can't figure this, well, you can figure it out, but it's not recommended. So this is the book, and we just talk about that. So then the question is, well, what happens when there's not enough beads? That's when we start talking about formula. In school, we're teaching this. We're teaching plus the 4 plus 1 is equal to 5. 1 plus 4 is equal to 5. If anybody who came in has a question, let me know. But I'm going to continue on with my little lesson. And what I do is I usually go all the way to adding and subtracting. How do you count the first number on the abacus? Oh, hey, Layla. So when we count it, we're going to do 1. That's what the first question. That's the first number. So when we do 1, we have 2. After 2 is 3 and 4, right? So what we're doing is we're just counting on the abacus. Then we notice that when we have 5, 5 will always be the top bead. So 5 will always be this, no matter what. No matter what. So if I did this, these are all counted. This is all 5. So what's 6? 6 is this, 5 and 6. Notice if I take away the 5, it's 1. If I add the 5, now we have 6. Does that make sense? So when we are doing this, we want to have 2. And then notice I'm going to add the 5. Now I have 7. When I do 3 and I add the 5, right? Adding the 5, now we have 8. And then we have 4. Well, after 4 and we add the 5, we have 9. Does that make sense? So what we just did is we just reviewed a little bit on how to read the abacus. And it's the same thing with all the others, right? So you're working with the numbers less than 10. So you can use any row. Yes, you can. You can use any row. That's a really good one. Yes. And what we're doing is we're utilizing this ones indicator. This is telling me where the ones is. This is a dot indicator. It's a label. This label tells me that it's the ones place. So when I look at it, this is the ones, the tens, the hundreds, the thousands, the 10,000. So now we can start talking about place value. That makes sense. Thank you. Oh, yeah, good. So what we're going to do is we can talk about place value. So notice that we have the decimal. The decimal sits between the ones and the tenths. So we can have the decimal sits here. This is not a decimal. This is the ones indicator. The decimal sits between the two, just like our decimal. Our decimal doesn't have a placement, right? It sits between the two. So we have our tens, right? This is like 9.1, 9.2, right? We have this one, 5,249, right? So, cool? Cool. All right. So we're going to continue on learning to read the abacus. Okay, good, right? Okay, good. So here is the thing is we're learning how to do this 5. The reason why, thank you so much for the like. So what happens is we have the 4. Well, what happens when I add another 4? Well, that's where we start talking about formulas. Okay. Why are we talking about formulas? Because now what we're going to do is we're going to utilize our numbers. We're not going to have any freeloading numbers. In mainstream math, there's a lot of freeloading numbers that are not doing any work. Well, in the abacus, because we have constraints, we have to start utilizing critical thinking. When we have critical thinking, then it's easier to understand how to do certain things. And one of the things to understand is, why are we doing it? So here's my question. Here's my question. Let's do 3. Let's do 3 plus 4. If I have 3 on the abacus, my question is I have 4. If I add 4, and I'm now, so here is my question. I have 4. I'm sorry, 3 on the abacus, I need to add the 4. I don't have enough beads to add 4. So just as we were teaching the children, we're teaching the children this. So we're teaching the children 4 plus 1 is equal to 5. This is a great concept to understand. Now, why are we using this? Because if you notice, we have this thing called the 5 bead. This 5 bead is what's going to work for us. So what we're going to do is we're going to isolate this variable. We're going to make it by itself. When we make it by itself, we want to subtract the 1. Why? Because we're trying to get to this. If I did this, this is too much. We want to balance the equation. When we balance the equation, I'm going to say minus the 1. Does that make sense? So what we're doing is we're going to add the 5. Adding the 5 is too much. So we need to take away the 1. So my final answer is 7. We can do it again. Let's do it again. So when we do it again, let's do 4. Notice 4 plus 4. We do not memorize our doubles. This is what we call doubles. We do not memorize doubles. What we do memorize is a formula. So when we look at the abacus, I have 4, and I want to add another 4. This is the 4 I want to add. This is the 4 I want to add. But guess what? We can utilize the 4 again, because now it becomes a little bit versatile. It becomes useful. It becomes workable. It becomes, right? Yeah. So that's what it is. So what we're doing is we're utilizing our numbers. We can actually see it and do this. We can do it again. So let's do 2, right? We can do 2. If we do 2, we don't have enough beads on the abacus. We don't have enough beads on the abacus to add the 2. What are we going to do? To do plus the 5, take away the 1. And there you go. And so my final answer is 6, right? Good, good, easy. This is a concept. This is the concept that we teach the kids, but then we throw it away because we don't teach them ever again. But in abacus, we actually utilize it and we make it work. We make it do something. So exactly, you're such a good student. That's exactly right. So we have this, right? If we have the 4, and I want to add the 3. There's not enough beads to add the 3. What do? You're absolutely right. If I want to add the 3, it'd be 3 is equal to plus the 5 minus the 2. Now, if you hear, I say plus the 5. These are like directions. Plus the 5, and I take away the 2. I'm not beating around the bush. I'm telling you exactly what to do. Add the 5, take away the 2. And this would be something that you'd be chanting, right? This would be something that you just keep saying, because as you say it often enough, you're going to remember it. You're going to memorize it, right? And that's what we do. And exactly the same as the other one, right? If you want to add the 2, right? If you want to add the 2, it's plus the 5 minus 3. Same thing. And so now what we're doing is we're compounding our math knowledge. We're compounding the information. This information we're compounding. And it goes again. We do 1 is equal to plus the 5 minus the 4. What? Yeah, right? It is simple. And it's not difficult. And I don't understand why they were talking about the lad. I was just so mad when she was like, it was so hard for me. But after I got it, I was like, what? No. So I don't know if you have this. I don't know if you can translate this. But here in math term, there's this thing called commutative property, and it's talking about the addition states that can change the order of the numbers. So we have the 5 plus 2, and it could change to 2 plus 5. I don't know. That's just something I found. We don't use it in abacus, just so you know. But I need to find terminology that's being used in mainstream math. Yeah, okay, good. But see, the thing is I never even knew this word existed until I started going down this path and putting in the internet. And I'm like, I don't know what this means. So that's what this is. But yeah, in abacus, we don't use the addition state, right? We use it for the formula. So we still have to modify it for the abacus. So in abacus, we can do it this way or we can do it the other way. We can do minus the 3 plus the 5. So notice, okay, so we have this, but now we added. After we added, what's going to happen? We have to subtract. Thank you so much for the likes. We can do subtraction. What? What do you mean? Exactly what I mean. Because what happened? Now we know the concept 3 minus 2 minus 5, right? This looks very familiar. So what's going to happen? Why are we going to do this? Because if I need to take away the 3, I can minus the 5 and then plus the 2. So now we know the reverse. So if I have 7 and I want to take away 3, I don't have enough beats to take away the 3. What do? I have my directions. Take away the 5 and plus the 2. Take away the 5 and plus the 2. And my final answer is 4. Does that make sense? And again, it's the same thing. We have the add 4, we have the minus 4. So when we look, here we go. So this is what we're doing. We're adding the 4, right? We add the 1. We can add the 5 minus the 4. Add the 2 is plus the 5 minus the 3. Oh, plus the 3 is plus the 5 minus 2. Plus the 5 is plus the 5 minus 1. It's so interesting to me because I never learned it this way. Yeah, you know what? There's a lot of people that didn't learn it this way. I didn't learn it this way. I learned how to memorize. But I learned abacus when I was 30, and then I taught my kids, and then we had a side business. We had hello, Blue Raptor, welcome back. So we have minus the 1, right? Just what I did, minus the 3. Minus the 1 is minus the 5 plus the 4. Minus the 2 is minus the 5 plus the 3. This one is minus the 3 is minus the 5 plus the 2. And then finally, minus the 5 plus the 1. So yeah, it's not a very common in the Eurocentric world. I think that's what it is. Because it's so popular in India, Singapore, Japan, China, all the eastern countries, they know of it, they know something of it. Some people still use it. But in the Eurocentric area it's not as popular, which is interesting. It's very interesting. But I think it's because nobody has taken the time to make understanding abacus in a Eurocentric math. So if you look, right, what I'm doing here is very similar to algebra. Does that look familiar? Is equal to 5. This is algebra, right? And what did we do? We isolated the variable. So we did x is equal to 5 minus 1. Funny? Yeah, I thought that was interesting too. So when we isolated the variable, then we substituted, right? We substituted this formula into here. Yeah. So there's a lot of abacus. There's a lot of abacus in algebra, and they go hand in hand. Abacus is the gateway to complex math. It lays the foundation, but it also feeds into algebra. There's a lot of things that's why I'm trying to find math terminologies that relates to abacus, because we do a lot of things in abacus that nobody knows because we do it in our heads, right? Nobody has really explained what we're trying to do. Hello, Sheridan. Welcome back. Yeah. let me know if you have any more questions. But yeah, I can continue on because the after that we can start talking about hello again. Hello, hello, it's you. Okay, so I'm in grade 11 as of right now. This is really useful in math. Thank you. Oh yeah, you're welcome, Alex. Yeah, no, thank you for the comments and talking with me because it doesn't make sense if it's just me talking. so so that's why it's very interesting on how abacus relates to algebra. Okay, so now we know how to plus the 5. We know how to plus the 5. Guess what? There's more. But wait, there's more. What does that mean? Well, if I have the number 8, no. But wait, there's more. If I did this one, let's do this one. Here you go. So here's my question. My question is, let's do this one, 8, or let's do 7. We'll do 7. When we do 7, right? We do 7. Oh, okay. Have a good day, Alex. I'll see you later. Thanks for the follow and thanks for the conversation. I really enjoyed it. So what we're going to do is we're going to understand how to make a 10. Oh, so anybody still here, let me know and what questions you have. If not, I'm going to continue forward or I'm going to go back. I can go back and review. We can go back and review. So we can go back and review. Always complainer, welcome back. So, okay. So here I am just asking who is in the room. If you're in the room, oh yeah. Yeah, you know what? Next time, let me know and we'll talk about how to make a 10. Let me know if you can remember. Tell me how to make a 10 and I'll tell you how to make a 10. Because that's the next step. That's the next step of adding and subtracting. Okay? Plus the 10. All you have to say is plus 10 and I'll remember. So, anybody else in the room? Hello? Bueller? Yeah. Not a problem, Alex. I see you in a little bit. 909090. Okay. So, anybody in the room? If not, hello. Hey, Layla. I told my co-teacher that we should teach abacus or now I'm building lesson book. Oh hey, that's what it is. So Sheridan, I was talking to another teacher friend, and if you wanted to, it is up to you. If you wanted to, I can come in and we could do a Zoom call, and I can teach the class if you're comfortable. If you're not comfortable with it, because the thing is my teacher, the teacher friend that I have, he was not comfortable with teaching abacus. And so I said, you know what, if you wanted to, I can, come through Zoom and we can teach the class together. So it's up to you if you want me to help you teach. And then we just have to figure out the time and your timing and stuff. But yeah, let me know if you have any questions about building out your lessons. So that's the thing. Yeah, I think it's fun. I think it's fantastic. But yeah. Well, I mean, it's just, Layla, do you have any other questions? Do you have any questions about what I've been doing so far? Hi, Matilda. Oh, Sheridan, do you have a 10-beat abacus? Now it's quiet. So that was the other thing. Let me know if you have a 10-beat abacus. Because if you have a 10-beat abacus, you can modify it. Not yet. I'm struggling to see. I don't have an abacus with me. I do. Oh, okay. Layla, hold that thought a little bit, and let me talk about. So Sheridan, did I tell you how to modify the abacus? Did I tell you how to modify the abacus? I don't know if I did. So I don't have one, but you can modify it. And what I would do is, ha ha. Hold on, Layla. So, Sheridan, I feel comfortable with the basics, but more complicated stuff is more iffy. You know what? Let me know, and then I can help you out. If you want, I am available to if you're comfortable with doing a cohort, I guess they call it. I'm missing the modification. Oh, I missed that. Okay, so here's the modification. So if I had a 10 beat, right? I don't say it very much because I don't know how many people have a 10 beat. So this is my 10 beat. Let's say I have a 10 beat, right? So this is my 10 beat. I would tape 5 beads here. Okay, you tape 5 beads and then you leave 5 beads on the side. When you are done taping, I would do all of it, right? I would do, 5, 5, 5, 5, 5. I would do every one of them. And then what I would do is I would flip it like this. So you don't need to buy an abacus, right? The reason why is I want you to use what you have. So after that, you get a string and you do that. Make sure the string's taut, right? And it would look like that. So what's going to happen is when you add the 5, right? We have 1, 2, 3, 4. We have 1, 2, 3, 4. And then we have 5. Then we have 5. And then we have 6, right? That's 6. We have 7. We have 7. We have 8. We have 8. We have 9. We have 9. Does that make sense? And then 10, right, would be like this. So this is 19. That would be 19, if that makes sense. So yeah, you can modify with what you have. And I would just ignore the bottom bead at the bottom because it doesn't need to be. It'd be like modifying. It'd be like what? It would be like the Chinese abacus. You just ignore the top bead and the bottom bead. This will work with all our 10 base block manipulators. Really? You have a 10 base? Yeah, okay. You would line it up like this? You could, but it's kind of a, yeah. Okay. That's cool. I don't use this though. But that's what I would do is and then if you wanted to, I don't know, it's up to you. You could use money, right? You could use money. You get a nickel, right? You get a nickel, you get pennies, and it'd be the same thing. If you wanted to bring in money, and it'd be 5 and then 6, 7, 8, 9. Just the manipulators I have the most of. Yeah. 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 That was the one thing is like the management on that would be kind of interesting. But you could, if you wanted to, you could also use money. I thought this was kind of an interesting concept to be able to use the nickel because some people may not. This is for like us, but for some people they didn't quite understand, so I used the nickel. So the nickel and then the 6, 7, 8, 9. You could use that too. Yeah. I would probably. Yeah. I don't know. That's funny. But yeah, when you work with it, I would probably just work with the 9 first before I started going into the place value, right? Because place value really happens with the columns. And then if you wanted to, if you don't want to spend money to buy an abacus, what I would do is I'd do a craft session and I'd make an abacus. You could do that too. And then they could learn how to count with something they made. Welcome back. What up? What up? Yeah, right, Sheridan. So you could do like a craft thing where they would make it, and then they can use it. I don't know if you want to do that. Let me see if I can find it. Now I'm like curious. If I had it, I would show you. Um, sorry, I'm trying to find my little craft thingy, and I changed a few things. Let's see. Is it back here? No. 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 All right. Well, anyways, if you want to, I like to use the money. I have my students to understand money better, and that would help. Yeah, that's interesting. What grade are you teaching, Layla? But yeah, the offer stands to any of the teachers, and I was like, I just want to let you know that if you want me to come in to teach, through Zoom, right? If you want to, we could set up a meeting where I can teach the kids how to use the abacus. If you're not comfortable with it, it's perfectly fine. That would be one of the things to do. I want to find my thing, but I can't find it. Okay, anyways, it is what it is. I'll find it next time. All right. So we had the question 7. So the question is 7 plus 4. So 7, oh, thank you so much for the hand heart, Liz. I'm learning math on the abacus at this point. I'm learning math with an abacus for aura points at this point. That's funny. Okay. Plus the 4. So the question was to add the 4. Now, if you notice when we add the 4, right, we have this. Oh, no, we don't have that. We had this. Where is the other one? Oh, here it is. So Layla, when we make a 10, this is what we do. We make a 10. Oh, fourth grade through, well, my fourth grade, fifth year are struggling with the years of the basics. Oh, okay. That's interesting. That's really interesting. So the maze might be good for the beginning part. Excuse me. Just to get them to know how to read the abacus, and then you can go into adding and subtracting, and then after that you can go into doing the formulas. And that was one of the plans that I wanted to do, was to create a workbook to start from fourth grade and then go forward. Ale. So what are we going to do? We're going to add the 7 and then plus the 4. When we add the 7, right, we have 7. There's not enough beads to plus the 4. Notice I don't have any more beads to add the 4. So I cannot add the 5, right? Because we have here our formula is to plus the 5. We cannot plus the 5. So what are we going to do? We have to utilize this 10 bead. This 10, the 10 formula. The 10 formula works exactly the same. This is now a pattern that we are utilizing. So if we look, we know that 4 plus 6 equals to 10. So when we modify it, right, when we isolate the variable, we do 4 is equal to 10 minus 6. Make sense? So what does that happen? Well, remember when we do 10, right? What does 10 mean? 10 means 0, 1. That's what 10 means. 0, 1. When we want to add the 10, we want 0, 1, and then we add the 1. And then we do is we minus the 6 here. So we minus the 6. So my final answer is 11. Does that make sense? When we look at this, and that's what I finally made a thing, because you can make like all these little gadget thingies. So when we do it, we want to minus the 4 plus the 4. There we go. So when we look at it, remember when we add the 10, when we make a 10, you're right. You're right. So when we make a 10, right? When we make a 10, it's just this. But it doesn't matter where we go. It can do this or you can do that. It doesn't matter. You can do this, you can do that. You can do this, you can do that, right? So the idea is when I want to have 7 and I want to add the 10, notice my 10 is a 0 and a 1. 0, 1. So I add the 1 and I take away the 6. Layla, does that make sense? Take away the 6. I got the wrong one. Right? Sorry, yes. Okay, good. Okay, good. So that's what we did. So what we're doing is we're understanding how to utilize this 10 formula. That's all we're doing. And it goes through all of them, right? It goes through all of these pairs. And each one of them is a pair. So when we do the 10 and the 9 and the 6 and the 4 and the 3 and the 7 and the 8 and the 2 and the 5 and the 5. Ah, Liz, thank you so much for the hand heart and the goat. And Beck, oh, thank you for the rose. I just now looked up. I was just so ingrained with and so involved with my abacus. I'm so excited for abacus. So I love learning new ways to do math. You know what? I love learning new ways to do math if it's easy. It's got to be easy and it needs to make sense, right? Me too, right? It's got to make sense. Like, why are we doing it? So I like the abacus because it gives a little bit of a constraint, but because of the constraint, it adds a little bit to critical thinking and analytical thinking, right? I don't want to just be doing things just to do things. I want to do it so that it makes sense to me. So there was the one speaker was like, yeah, the lattice one, it's really useful, but it was really hard. And I'm like, I don't want to teach that if it was hard. I don't want to teach something that's difficult, because if it's difficult, then it takes too much of my brain power to do it. You know what I mean? So So that's how we do the 4. We can do the same thing. Let's do the same thing with the 9. We can do the same thing with the 9. The 9 is easier. The reason why is because we have more numbers. We have more numbers to play with. So when we look, we have 4. We're going to do this one here. We're going to do 4. We add the 4. We want to plus the 9. Plus the 9, we know what to do. We know what to do. What is it that we're going to do? We are going to do 9 plus 1 equals to 10. So then what do? We have this and we move it over here. So we isolate the variable. If you notice, we did something like this is equal to 10. Woo! Right? This is algebra. Because this is algebra, what we need to do is we need to move it over there. So we isolate the variable. We do 9 is equal to plus the 10 minus 1. If I replace the 9 is equal to plus the 10 minus 1, right? We make the 9 by itself. So what are we going to do? Plus the 10. We plus the 10. So remember, 1, 0 plus the 10. So we add that and we take away the 1. We take away the 1. So my final answer is 13. When we rewrite the formula, what we did is we substituted this information with the 9. So now we're talking about critical thinking. No, we're talking about algebra. So it's more like algebra, right? We substitute stuff. So this leads into algebra. Anybody have any questions? But I do like, we could keep going. So we could do the whole gambit. So we do 3. I don't know if you could see that. Oh, you know what? I'm going to do this. No, this. No, this. Come on. No. Oh. Now I'm just playing with my camera. There we go. There we go. So we could do the 3, right? We have the 3. When we do the 3, it's the same thing, right? We go 3 and then plus 9. When we add the 9, all we have to do is plus the 10. That means it's 1 and 0. 1, 0. 10, and then take away the 1. And that's it. So my final answer is 13. Anybody else? Are we okay? We want to do another one? We can do another one. We can do another one. I was just thinking, what was I thinking? I was thinking of, so this is what we're doing. Now, if you notice, I don't know if this is what, yeah, we can do another one. So what we're doing is, this is the simple, right? This is the Bob the Builder phase. This is the simple one because we have enough beads. When we have enough beads, that's what we're doing. So 2 plus 2, 2 plus 2, that has it, right? And then we did the 5. After we did the 5, right, we have 4 plus 3 plus the 5 minus the 2. So this, the pink is the adding of the 5. And now what we're doing is we're adding the 10. So the 10, adding the 10 is a little bit more. So let's do 4 plus 8. So we do 4 and we plus the 8. Plussing the 8. What is plus 8? Plus the 8 is, oh, hold on, Hale. Plus the 8 is plus the 10 minus the 2. So when I plus the 10, right, 0, 1 plus the 10. 0, 1 plus the 10, which is plus the 1. I'm adding the 1 and I take away the 2. So my final answer is 12. So each column is like a place value. Yes, Ale. Yes, exactly. So when I have my place value, here it is. When I have my place value, that's what it looks like. That's my place value. So my 1s, my 10s, my 100s, my 1000s, my 10,000s. Does that make sense? So when we look at it, we have 12. When we have 12, so is the blue bead in the tens place worth 50? Yes, exactly. So if I did this, this would be 50. Exactly. So when I have this, it'd be 70. I'm sorry, 60, 70, 80, 90. I can count by hundreds, count by tens. Now what I can do is I can count by hundreds. Every column, right? Yes, not a problem. No, thank you for the comment. Thank you for the question. Always ask questions because I don't know what you don't know. Right? So I can count by hundreds. 100, 200, 300, 400, and then 500, 600, 700, 800, 900, right? And then after 9, just like how we write, what's after 9? We got to go to the next number. So this is what we call a 10 base. This is a 10 base. Our number system is 10 base. This is a 10 base and it mimics the way we write. So when we do 10, right, this is 9. So it's a 0 and a 10. But then we have these columns, right? We want to count these columns, so it'd be 1,000. So I have my comma, right? That. So 1,000, 1,000, and then decimal. We have our decimal. Our decimal sits between the ones and the tenth. It does not have a place value. It sits between the two. It sits between the two place values. So this is my tenths and my hundredths. Yes. Thank you. No, let me know if you have any questions, anything you have questions about. It's always good to answer the questions because you'd get stuck. And I want people, this type of math is fun. Yes, I think so too. I think so too until I have to get my kids to do it. And they're like, I don't want to do more abacus. I'm like, you got to do it. They hated it. They hated it. But it gets a little monotonous after a while. That's why I made my worksheets because I didn't want it to be monotonous. The kids will always complain no matter what, like to do any kind of work. So I'm trying to make it a little bit more fun, and that's what it is. So we can do another one, right? We have this one. We did 3, now we can do 2. And if you notice, it's the same concept. The question is do we have enough? Yes, we don't. Thank you, Liz, for the roses. Wow, time's up by 38. So if you notice, we don't have enough to add the 9. What do? We know our formula. Our formula is plus the 10 minus the 1. Remember when we plus the 10, what does that mean? When we add the 10, it's the 1, 0, and 1. 0, 1. That's adding 10, right? So we want to make sure we understand. We want to add the 1, and then we need to minus the 1 because that's what we're doing is we're doing the 10. We're doing plus the 9. So plus the 9 is equal to plus the 10 minus the 1. So our final answer is 11. And then we can do another one. But let's do another one. Okay, you know what? Let's do this side. Oh, you know what? Let me do this. There we go. Okay. So let's do this way. I can move my camera. All right, so let's do that one. When we do this, it's exactly the same. When we have the 8, and I want to add the 9. When I add the 9, what do? It's plus the 10 minus the 1. So again, a lot of this information is being compounded. When we compound this information, it builds on top of each other. So this is what we do is when we add. Now we know how to add. What are we going to do? We're going to subtract. So what does subtraction look like? It looks exactly the same except with opposite operators. The opposite operators. What does that mean? Well, when we are trying to take away the 9, right, and we're trying to take away the 10, it's minus the 9 minus the 1 equals minus 10. And then it looks very familiar, doesn't it? So what we're doing is we're going to isolate the variable. We do minus the 9 equals to minus 10. That's too much. We need to plus the 1. When does that happen? It happens when we subtract the 9. So if we did 16, we can do 15. 15. Let's do 15. 15 minus 9. 15 minus 9. I need to take away the 10, and I need to add the 1. I'm going to add the 1. So my final answer is 6. Does that make sense? There we go. So my final answer is 6. And it's the same thing. If I had 18, right? If I had 18 and I want to minus the 9, I need to minus the 10 plus the 1. I take away the 10 and I add the 1. My final answer is 9. Great, Layla. Right? So now we know how to add the 5 and we know how to take away the 5. We add the 10, we take away the 10. That is the secret to all math. No, that is the secret to all adding and subtracting. What does that mean? You have everything. Now you have everything you need to know to add any type of adding and subtracting any numbers whatsoever. Now we got to Tetris our way through. What does that mean? We got to Tetris our way through. We got to build upon it. We're going to build our information on this. Are we ready for that, or do we want to do more one digit? Are we ready to start building, or do we want to do, it's called a two-step equation. Are we ready for two-step equation, or do we want to continue on with understanding the formulas? It's not basic. It's not basic. It's fundamental. Let's build. Okay, let's do it. Let's do it. Okay, great. Hello, welcome back. Welcome back. We're starting into doing some two-digit equations. Two-digit. I finally, right? That's what I'm saying. That's what I'm saying. Welcome to the real world. You have now taken the red pill. Fantastic. Thank you. No, thank you, Hep. Thank you so much. Thank you for the follow. Okay, what we're going to do is we're going to do two-step equation. What does that mean? Now we're going to start building. When we start building, we need to understand why we're doing it. So the question is, we have one question and one question only. No, we have more questions. 7 plus 7. When we do 7 plus 7, again, we do not memorize our doubles. What we do memorize is our formula. We know how to add the 7. So we have the 7, right? And now we add another 7. When we add another 7, we know plus the 7. What is our formula that we're going to use? I'm going to make you guys work. Hi, Lisbeth. What is the formula that I need to add the 7? This will help jog your memory. Let me know. How do I add the 7? What is the formula to add the 7? Thank you, everybody, for the likes. Thank you, everybody, for the likes and the follow. Thank you, Catherine, for the follow. Yes, Layla, you're absolutely right. We want to plus the 10 minus the 3. Exactly. So when we do it, right, we plus the 10. 10 is 0 and a 1. 0, 1. We're going to add the 1. And now look, we want to minus the 3. We cannot minus the 3. This is what we call two-step. Why? Because this is no longer simple. We now need to do something with this minus the 3. We need to take away the 3. How do we take away the 3? We know this. What do we do? What do we do? There's no freeloading in my room. No freeloading. Sleepy, wake up. Wake up, Sleepy. Exactly, Layla. Exactly. So we're going to minus the 5 and we're going to plus the 2. This is what we call a two-step equation. Does that make sense? When we do, because why? This is what gets substituted in. Minus the 5 and then plus the 2. Now my final answer is 14. So what this is we just build on our concepts. We built everything. We understood it, right? Hello, Ashlyn. We built it. This is what we did. We had our foundation. This is the foundation. Now we're critically thinking, how do we make our numbers work for us? We don't want to have any freeloading numbers. Does that make sense? So when we look at it, we can do another one. So I had a parent. They're like, you know what? I want them to know what this is. It was this one. It was 8 plus 5 and then 5 plus 8. Isn't that the same? No. Why? Because it's all about the add-in. We know this add-in, right? We do 8. Let's do this one. We do 8 on the abacus, right? We do 8 on the abacus. We want to add the 5. When we add the 5, what do? Plus the 5 is equal to plus the 10 minus the 5. So I'm going to plus the 10 minus the 5. Easy, right? So my answer is 13. I should have more room on that. Okay, so the next one is what? The next one is this one. I have the 5. Now I'm going to add the 8. We know how to add the 8. What is the formula to add the 8? Thank you so much for the heart. Wow, 7,000 likes on this one. Wow, thank you guys. Hello, Sean. So what would be the formula to add the 8? Yes, thank you, Sheridan. Plus the 10 minus the 2. So I'm going to plus the 10. But I need to take away the 2. Now what do? I cannot take away the 2. This is why it's a two-step equation. Hold, please. This is why it's a two-step equation. Because now we need to understand how to minus the 2. How do we minus the 2? We cannot minus the 2 because we have this. Exactly, Sheridan. So it's minus the 5 plus the 3. So what we're going to do is minus the 5 and we're going to plus the 3. So my final answer is 13. It is not the same because we're focusing on the add-in. This is why it's different. Does that make sense? This is why it is different. We don't focus on the sum. We don't focus on the result. We focus on our add-in. This is why you have to be careful with the addition. You have to be careful when you add because the kids will get confused if you're using the abacus. So this is what we call two-step equation. This is a two-step equation, and then but they have to really be solid in how to add the 5 and take away the 5. Is it a problem? It's not a problem, but if they're weak in adding and subtracting the 5, they're going to be weak adding and subtracting the two-step equation. Because if you notice in the 5's formula, in the 10's formula, there's the same redundant numbers. The question will always be, can you add the 5 first? If you can't, then you do the 10's. That will always be the question. Can you add the 5? Would it be easier or quicker to input larger numbers first? It doesn't matter. No, it would not be easier or quicker. I don't know, actually. You know what? I have to think. I'm sorry. Let me think about that. So if you had no, I don't think so. you could reverse it, but then you would be weak in it, right? So if we had the 5, and we reversed it. If we had the 6, but then we had, oh no, you know what? There we go. So no, here, no. You know why? Because 6 and 8. Let's do 6 and 8. That's a good question. That's a good one. So let's do 6 and 8. So we do 8, and then we do 6 plus 8. Let's do that. So we do this. We have 8, and then we want to add the 6. Can we add the 6? No, we cannot add the 6. What are we going to do? Well, we know plus the 6 is equal to plus the 10 minus the 4, right? Plus the 10 minus the 4. We want to plus the 10, take away the 4. Take away the 4. When we take away the 4, we can't do it, right? So if we can't do it, what are we going to do? Minus the 4 is equal to minus the 5 plus the 1. So we minus the 5 plus the 1. My answer is 14. Okay, we got that, right? We're okay? Now let's do this one. We want to do 6. When we do 6, we want to plus the 8. Plus the 8 is equal to plus the 10 minus 2. So I want to plus the 10, and I need to take away the 2. But notice I can't take away the 2. So it could be easier depending on what the number is, but in any which way, you still need to be solid in the formulas. We want to minus the 2. So we minus the 2 is equal to minus the 5 plus the 3. So we minus the 5 plus the 3, and my final answer is 14. That's a very good question. Thank you, Hep. That's a very good question. Neri, yes, you're absolutely right. It is 14. But we're talking about abacus. Hi, Domo. Yeah, that's a very good question. So there's some things that you could do. So even like 6 and 7, we would still have that same problem. 6 and 7 would have the same problem. So yeah, you could, but you have to be careful. Okay. But it's still, but yeah. Excuse me, Neri. What we're doing is we're doing abacus, and the first thing we need to do is understand how to read the abacus. So let's do a little review. Yeah, not a problem. No, thank you so much for the question. That's a really good question, right? But I think those were the only two. Yeah, anyways. So Neri, if you're still here, we're going to count. 1, 2, 3, 4. I have to go. Definitely will be back earlier to the next one. Yeah, see you later, Layla. Thank you so much for joining. Let me know how it goes. But I hope you introduce abacus to your students. I think it's the greatest thing since sliced bread. So, Neri, I don't know if you're still here, but we're going to count on the abacus. This is 4. When we add 4, right? 1, 2, 3, 4, and then we have 5. 5 will always be the top bead. Because we have 5, then we're going to do 6, 7, 8, 9. After 9, we have 10. So does that make sense? 10? Domo, you're still here? Let me know if you guys are still here. If not, I'm going to continue on adding and subtracting. Okay, so here is our 1s, our 10s. Hey, Domo, thank you. So did that make sense on how to read the abacus? Because what we're doing is we're understanding how to read the abacus. Okay, great. So we have our 1s, our 10s, our 100s, our 1000s, our 10,000s. So if you look at the abacus, we can actually see our place values. 1s, 10. So this is 10, right? 1, 0, and then this is 11, this is 12, this is 13, this is 14, and then 15. All the top bead will be a value of 5. So if I did this, if I did that, that would be 5, 5, 5, 5, 5, 5, 5 with the decimal. So why is that the 1? Because I have my indicator. If you notice, I have this dot indicator, I have this 1s indicator, and this will tell me why this is the 1s place. So because I said that this is my 1s, just like in Pokemon, right? I choose you! This is my 1s place. So I could choose this one, but then notice I would have to move everything over, and then this would be my 1s, my 10s, and then notice I don't have any 100s. I don't have any more I don't have any more columns for the 1s, or for the 100s. I could put it back, right? So I have my 1s, my 10s, my 100s. So my 1s, but then notice after the 1s is my 10ths and my 100ths. That means this is my decimal point. So because this is my decimal point, this is where it sits. The decimal sits between the 1s and the 10ths. It doesn't sit on a column. So just as we write we write $1.25. That's what that means. $1.25. 1.25. Does that make sense? Thank you so much for the hearts. Wow, I'm almost at 10K. Wow, you guys are awesome. Got it. Okay, good. So, unnamed ghost. Oh, I feel sad for you, unnamed ghost. Thank you for the likes. So what we're going to do is when we read it, right, you're going to always be 9. 9 will be the most. 9 will always be the most. So this is 9. 9, 9, 9, 9, 9. So when we write it, it would be 99,999.99. That's what that means. That's what that means. Ale, are you still around? What's going on? You're very quiet. Sheridan's still here? Okay, so that's what we're doing. And what we did is we actually understood is how to read the abacus. After we read the abacus, we're going to start moving the abacus. So that's why we start talking about the adding and subtracting. We need to understand these formulas. Formulas is beneficial because we need to understand when there's not enough beads, we need to start using formulas. But the first thing we need to do is understand how to move the beads. So when we add the 2, we're going to add another 2. So notice I'm adding these 2 beads. Okay, so when we add the 2 beads, that's all we're doing. It doesn't matter which 2 beads. It says, hey, Sheridan. Okay, you're going to go, no problem. Have a good one, Sheridan, and let me know if you have any questions about abacus. So, and then they're flipping forward. I'm absorbing the information before I ask questions. Oh, my God. Okay, as long as you ask the questions, Ale. Domo, hey, Dave, welcome back. So what we're doing is we're adding 2. Notice when I add the 2, I can subtract the 2. I'm subtracting the 2 means I'm taking away from the horizontal bar. So when I add the 2, I go to the horizontal bar. When I go away, when I subtract, I take away from the horizontal bar. Does that make sense, Domo? So same thing with the 5. When we add the 5, we go to the horizontal bar. When we subtract the 5, we go away from the horizontal bar. Let me know if you have any questions. Oh, my goodness, it's already 1:45. Okay, so this will be it, I guess. So I'm going to be ending the live pretty soon. Should we show us a problem? Yeah, we can show you a problem. Let me show you a problem. So the first thing we're going to do is, let's do this one. Let's do the favorite one. Okay, my favorite one is this one. The reason why it's favorite, because it's easier to show. So the first thing we're going to do is understand the 2, right? We're going to put 2 on the abacus. We're going to put 2 on the abacus, and now we want to add the 4. We're up here. My eyes are up here. So what are we going to do? Well, notice we want to add the 4, but there's not enough beads to add the 4. Well, what are we going to do? Well, what we do is we know this formula. We know this concept. This concept is plus the 4 is equal to plus 4. 4 plus 5, 4 plus 1 is equal to 5. This is a concept that we're teaching the children, right? We're teaching the children how to use this concept. This is great. This is what we do on the abacus. We do this on the abacus as well, but we do it differently. So the first thing we're going to do is we're going to understand that this is the formula, this is the number expression. And what we need to do is we need to isolate this variable. We're going to isolate the variable. If you notice, it's very similar to algebra. Algebra looks like this, right? So when we do it, we want to isolate the variable. We want to isolate the x. When we isolate the x, we need to make the 4 by itself. We want to subtract the 1. So what's going to happen is if I do 4, I want to say equal to 5. When I say it's equal to 5, that's too much. Well, why are we adding the 5? We're going to add this top bead, but now it's too much. We need to subtract the 1. So when we subtract the 1, my final answer is 6. So 2 plus 4 is equal to 6. Now, if you notice, I'm not memorizing doubles and doing strategies. What I'm doing is I'm showing you the formulas. This is fundamental building blocks that we need to understand. So we can do another one. So here is 3. When we add the 3 on the abacus, notice I don't have any more beads to add the 4. But wait, there's more. Because I know how to add the 4 using the 5, plus the 5 is too much. I need to minus the 1. So what I just did was I repeated, right? I utilized the formula that we've already been taught. Now we're solidifying, we're repeating and we're practicing. We're repeating and we're practicing because now we have the different scenarios. So my final answer is 7. How do I know? 5, 6, 7. So when I have 7 here, we can do it again. And the final one would be this, 4 plus 4. Again, we don't memorize our doubles. What we do memorize is our formula. So when we have 4, the question will always be, can I do it? How can I do it, right? This is not a yes, we can. This is a how can I do it? Why? Because now I don't have enough beads to add the 4. Because I don't have enough beads to add the 4, what do? I know I can use the formula. To use the formula, all I got to do is plus the 5 and take away the 1. And my final answer is 8. Did that make sense, Domo? So that's the little bit. So again, if you notice, because we do the, yes, thank you. Oh, because we do that, right? If you notice, if you notice, right, every one of these has a 5. So that means that I could do 5. If I want to look for 3, I can plus the 5 minus the 2. It's the same thing with the 2. If I want to add the 2, so if my question is 4 and want to add the 2, all I got to do what? All I have to do is add the 5 and take away the 3. Now this is a concept that we can repeat and understand. This is critical thinking that we're adding. We're adding critical thinking. Like there's ways to do it. How can I do it? What are the ways? Let me count the ways to do it. I have to go, but I can't wait to catch the next live. Thank you for teaching all of us. Yeah, not a problem, Sheridan. Not a problem. Thank you for asking questions. Let me know if you have any more questions, and I will be on later. I don't know. I don't know if I'll be on later, but I'll be on in my next live. You will see me in my next live. Have a good day, Sheridan. All right, Doma, does that make sense? So that's why it's critical to understand the concepts, right? When you understand the concepts, then it's easy to relate it. And then because we know how to do this, we know how to do it with the plus 10s. But that will have to be in my next live because I am going to sign off. I need to get ready for track. I have a track meet to go attend. Yeah, thank you. Thank you, Heb. Thank you so much for that question. That was a really good question. I do appreciate that one. I'm going to start using it now. Yeah, thank you. Take care. You too, Heb. Thank you so much. All right. Okay, Domo, if you have no more questions, if not, you can tell me, you can find me on my next live and you can ask me then. Thank you so much. All right. So, Domo? I don't know if Domo's here. Okay, Domo left. Domo left. Okay. Okay, Domo. Okay. I just like that name. All right. Have a good day. Thank you so much. Goodbye, everybody. Bye, Ale. Hopefully you're still there. I see you, but I don't see you. Okay. I'm just cleaning up my stuff. I'll see you in my next live. Hopefully you come with questions, right? Come with questions. All right. Let's see. Oh, good. Love the questions. I like to be challenged. It's always a good challenge. Yes. Cool. Cool. Have a good one. Bye, Rebecca. I didn't see you there.